Chapter 6, Your First Ethereum Smart Contract. Within this chapter, we're going to dig deeper into smart contracts, the Ethereum platform's backbone, and later you're going to create your own smart contract so you can get an idea of what to do and how they work. You would need to learn how to use the command line for this, and you will also have a good computer programming comprehension. You will need to update Geth if you haven't already got it. The smart contract is an account which holds blockchain objects. Each has code-written functions, and they can communicate with one or more other smart contracts. We can also make choices, store data, and transfer ETH to other users. A contract is specified exclusively by its creator, but the Ethereum network carries out the execution of the contract and the services it provides. The contract will be in place and executable as long as the entire network is in operation, and will only be executed if it is programmed with a self-destruct command. So, what can you do with these contracts? The best issue of these contracts is, what do you intend to do? Smart contracts can also be used for all kinds of stuff, from a basic contract to something much more complex, from "I'll pay you with this much on this date." We're going to build a really basic contract, the Hello World contract, to give you a better idea, and then we're going to build a crypto token you can pass on to whomever you want. When you have the hang of that, you can move on to raising funds through crowdfunding, and if it is effective, it can have a decentralized and fundamentally open entity that can only bid on its own members, would never go against its own constitution, and has no means of being censored or even closed. And you can do all of that in 300 lines or less of code. Let's continue. You'll be the greeter, your very first resident. This is an automatic companion who will chat with you and welcome you anytime you feel a little lonely, because the frontier is a lonely place, let's face it. The greeter is a digital object that resides on the Ethereum blockchain and is very intelligent. He will have a conversation with anyone who communicates, depending on the feedback, and while he may not be able to talk verbally, he is a great listener. Did you note we have two different contracts here when you were typing away? One mortal and one greater. The explanation for this is the language of high standard solidity, which we use is a language that embraces inheritance. What that means is a contract will inherit one or more features from another contract. It is tremendously supportive and allows us to simplify the code because we don't need to rewrite any features specific to the contracts. And this leads to smaller contracts, which are better written and simpler to understand. So when we declare the greater to be mortal, we inherit the characteristics of the mortal contract and keep our code far simpler. The characteristic of inherited mortal means nothing more than that of the owner can kill off the greeter contract. It will be done as a way to clean up the blockchain and recover any funds that could be locked into it when the contract is completed and no longer needed. By nature, Ethereum contracts are immutable and have no owners, which means that once deployed, the creator or owner no longer has any rights. Be mindful of this before deploying your contract. The Solk compiler. Now, you need two things before you can deploy these contracts: the node that was compiled and the ABI application binary interface. This is a JavaScript object which defines the contract interaction. The first component, the compiled code, needs a compiler, and you should already have a Solidity compiler on your Geth console. To check, type in this command, eth.getCompilers. If it is installed, you will see something along these lines: Solidity. If you don't, then install it or continue to the section below on using the online compiler. Using online compiler. If Solk compiler is not set up, you can use the online compiler. Just open the Solidity compiler online and enter the code eth.getCompilers, and you will see the compiled code in the left panel. Look for the Web3 deploy box and put in the code, the mortal contract, all one word, and the greeter contract, all one word, into the one text file. And then modify the first line to your preferred greeting in that text file. And then write out the word var, V-A-R, and then space, greeting, equals, quote, hello world, quote. Now copy the resulting text to your Geth console window, or if you like, you can import the script using the command load script, parenthesis, name of your .js script, parenthesis. Wait about 30 seconds and you should see something on your screen. The gas cost of contract delivery must be charged so that you may need to access the account that will deliver the transaction. To do this, use the password you have selected when setting up Geth. This specific contract would require a deployment of at least 180,000 gas. And the price was about 0.702 ETH per gas unit at the time of writing this. The developers on Ethereum will not be paying this cost. It is given to the miners as their incentives for discovering a new block and keeping the entire network safe. The gas price can fluctuate and is dictated by the calculations, supply and demand. If the worth is too much, you might consider becoming an Ethereum miner and lowering the price you ask for. Return to the contract. You will see a log that has the contract address in it in less than 60 seconds. This ensures that the contract was successfully executed and the code can be checked with the following command: eth.getCode, parenthesis, greeter.address, parenthesis. If you come through 0x on your screen, you were unsuccessful. Everything else could confirm that your greeter is now live. When you recreate the contract using the, all one word, eth.sendTransaction command, it will be released to another address, not the same address. Run the greeter. Simply enter this command in the terminal to call the greeter. Greeter.greet, parenthesis, parenthesis, semicolon. This call will not alter anything in the blockchain so that the return will be immediate and there will be no gas costs associated with it. You will see these: hello world. Getting others to interact. If other people are going to run this contract, they would need the contract location address, and the ABI is a sort of user manual explaining the feature names and how to call them in the JavaScript console. To get them to execute these commands, greeter-compiled.greeter.info.abi definition, semicolon, greeter.address, semicolon, all one word. Cleanup. So the very first contract went live. Unfortunately, the excitement that comes with this can wear off quickly, particularly as contract owners write more contracts and vacate the old and deserted ones on the network. There's a possibility that sometime in the future, a blockchain rent might be implemented to help improve blockchain scalability, but for now, it's up to you to delete your abandoned contract by enforcing the self-destruct click. To do so, you need to submit a request to the network, and you have to pay a small fee because you're making a shift to the blockchain after running the code below. Self-destruction is actually being subsidized by the blockchain network, so it doesn't cost nearly as much as a regular transaction anywhere. Enter this code: greeter.destroy.sendTransaction, parenthesis, curly bracket, from, eth, dot, account, bracket, 0 bracket, curly close bracket, close parenthesis. Only the contract owner may send the correct transaction to cause this, and in order to check whether it has been completed, you should enter the following code. If it has been completed, you will see the result 0, eth.getCode, parenthesis, greeter.address, close parenthesis. Every contract will execute its own destroy clause, and in this case, it must be done by means of this.